My name is Wayne Ottinger. My career in aerospace started in 1955 after graduating from the University of Arizona as a mechanical engineer. My early experience included flight testing of jet engines on the first Mach 2 aircraft and the X-15 rocket research airplane propulsion system. For Apollo, I was the NASA project engineer for the Lunar Landing Research Vehicle, or LLRV, and the technical director for Bell Aerosystems on the follow-on trainer, the LLTV. I have some real hardware to display for you, and we'll show a few slides to give you insight on their significance. As you can see from this chart, providing redundancy for 3 axes of flight control gets complicated. The reaction control system for the LLRV required both redundancy and a system design accommodating specific rocket engine locations on the vehicle and corresponding symmetrical placement of the propellant feed system tankage and components to achieve dynamic balance or fuel management during flight operations. Each rocket is fired in a test stand, and the thrust is adjusted to performance specifications by use of orifices controlling propellant flow. For research flight tests, the attitude rockets were adjusted from 18 pounds of thrust to 90 pounds. Depending on the test mission requirements, the test set of 8 rockets were adjusted accordingly and installed on the LLRV. The standard set of 8 rockets were usually set to 60 pounds. Both sets could be used if needed at any time. I have here to show you a Catalyst stainless steel screen coated with silver that came out of the LLRV 90-pound thrust attitude rocket. As you can see in the previous slide, they are packed tightly in the rocket motor chamber. Shown here is one of 4 attitude control rocket clusters located symmetrically at each of the 4 corners of the vehicle, as shown in the next slide. This photo shows the hydrogen peroxide propellant system after a hot firing of the rocket system being purged with gaseous nitrogen through the helium pressurization system. This system was used to feed the hydrogen peroxide fuel to the 16 attitude control rockets and lift rocket system of 2 500-pound normal lift rockets used for lunar simulation mode, and the 6 emergency lift rockets, which were never used. This X-15 100-pound thrust attitude rocket, which I will pass around, closely matches the LLRV 90-pound thrust rocket, both made by Bell Aerosystems of Niagara Falls, New York. After the LLRV research flights were completed, the 6 emergency lift rockets were removed prior to sending the 2 LLRVs to Houston for astronaut training. Fortunately, they never had to be used in the flight research program at NASA DFRC at Edwards Air Force Base. The seatman separator here is the one actuated in Armstrong's ejection shown in this slide, and has been x-rayed indicating no propellant remains in the actuator cartridge chamber. Notice the harness the pilot sat on is wound up into the retracted position from the ejection sequence. The X-15 achieved 4,520 miles an hour and 354,200 feet altitude. This XLR-99 engine 2-stage igniter was operating at 800 pounds of thrust before the aircraft was released from the B-52 carrier aircraft, usually at around 40,000 feet altitude.